Hello guys, welcome. Welcome to Ashutosh Coach. Now today we are going to starting the chapter name is wave optics. तो wave optics होता क्या है? Wave optics is a branch of optics that deals with the behavior of light and rather as a particles, and it is a crucial topic is understanding that the nature of and the light and the interaction with the matters. Okay, and the sum of the key concept concert covered in a wave optics: interference, diffraction, polarization, reflection, and so on. Okay, wait for a second. Now model of light देखते हैं. Light can be modeled in two ways, as a wave, and these models as known as particle model and a wave model of light. Particles model of light. The particles model of light, also known as the corpuscles model, and according to the particles model, the light consisting of tiny packet of energy called photon, and which travels in a straight lines and have wave like and particles like property. Wave model of light क्या होता है? According to the wave model, the light transverse electromagnet and the forms through the space, and this model is useful in the explaining phenomena and such as interference, diffraction and polarization. Hygiene principle क्या कहता है? Hygiene principle state every point on a conferent can be considered a new source of secondary spherical wavelet. In other words, hygiene principle state that the wavefront at any point in the can be reconstructed from the secondary wavelet and that are produced by each point on the previous wavefront. Okay, reflection of plane क्या कहता है? Waves using the Huygens principle. When a plane wave encounter a reflective surface, and each point of the wavefront will reflect and from a new wavefront after reflection, and is found by the tracing path of all secondary wavelet and the finding the envelope and these paths. Let us consider a plane's wave and the AB incident at an angle and I on a reflecting surface. Okay, इसको ध्यान रख लेना, ये बहुत काम आएगा आगे जाके. कहीं पढ़ोगे ये बहुत इजीली काम आता है और भी बहुत सारी चीज़. ओके, लॉज ऑफ रिफ्लेक्शन कैसे प्रूव करते हैं? हाउ टू प्रूव बहुत इंपॉर्टेंट आएगा. ओके, अब रिफ्लेक्शन ऑफ प्लेन. आप भी इसका स्क्रीनशॉट ले ले और अपने किसी जाने माने को भेज दे, ज़्यादा बेटर होगा. मैं भी भेज रहा हूँ अपने साथी को, दोस्त को. जाओ भाई, अब इसका बाद में इसका सारा आंसर लिख के पढ़ाई करना. ओके, यहाँ तक कोई दिक्कत? रिफ्लेक्शन ऑफ प्लेस waves using the Huygens principle. देखो, when a light planes when a plane have encountered a medium with a different reflective index, and each point of the wave front will reflect at a different angle, and a new wave front is then found by the tracing and the path of all secondary wavelet and the finding envelope of these paths. ये सब को आप नोट कर लीजिएगा. ये सब समझाना चाहिए नहीं है, पढ़ाना चाहिए होता है. इसको बस दिमाग में रखा जाता है और इसको सॉल्व कर लीजिएगा. और कोई दिक्कत हो तो कमेंट में आप बोल सकते हैं, मैं ऐसे भी सॉल्व कर अलग वीडियो बना दूंगा. उसके बाद आता है रिफ्रैक्शन ऑफ प्लेन वेव्स यूजिंग हाइजेनबर्ग प्रिंसिपल. देखो, अ वेव फ्रंट इज अ surface that represent the disturbance produced by a wave as it travels through a medium, and its boundary between the two regions of a medium that have a different amplitude, and it describes the process of the wave through the space time. The types of wave front क्या होता है? In optics, wave physics, and there are three main type of wave front: converging, diverging, and plane. Converging में क्या होता है? When occurs when light waves are coming at a point, yeah, coming from at a point, or the source converges towards the single point, and this often to seen optical symptom like lens, and when light reflected to a focus. Okay, diverging a wavefront क्या होता है? The occur when the light waves are spreading out from a point and becoming more than one spreading or part, and this can be seen in the case of diverging wavefront produced by a point source, or a cylindrical diverging wavefront and produced by extended lines such sources. The plane wavefronts occurs when light is traveling in a flat and uniform wavelength wavefront, and the type of wavefront is produced by a source at a infinity, such as light from a distant star. फर्स्ट है तुम्हारा कॉन्सेंट्रिक, उसके बाद सिलेंड्रिकल, फिर प्लेन. इसको भी ध्यान रख लेना, बहुत काम आएगा. इसको डिलीट करो, साथ में इसको नहीं लेना, इसको डॉपलर को ले लेते हैं ताकि किसी के काम भी तो आए. वेट, इसको भी अपने किसी फ्रेंड के पास, 1 मिनट हुई इसकी, लॉन्ग लॉन्ग सर्किट हो गया. इसको शेयर करना है, शेयर करो, किसी की भलाई करो. इसे भी भेजो, काफ़ी काम आएगा इसके भी. अब नाउ स्टार्ट करते हैं. ठीक है, तो यहाँ तक कोई दिक्कत था नहीं. अब हम लोग पढ़ते हैं डॉपलर इफेक्ट क्या होता है. डॉपलर इफेक्ट ऑल्सो नोन एज द डॉपलर शिफ्ट, एंड इज द चेंज ऑफ फ्रीक्वेंसी ऑफ वेव और वेवलेंथ of a wave in a relation between an observer who is moving relative and the source of waves, and it is named as the Australian physicist and the Christian Doppler, and was the first discovered effect in the 1842. When a source is moving away from an observer, and the observed frequency will be lower than the actual frequency, and the causing red shift, and when a source is moving towards an observed frequency will be higher than the actual frequency and causing the blue shift. Coherent and the incoherent addition of waves. Coherent and the incoherent waves addition are the two methods of combining or more waves to form resultant wave. Coherent wave addition क्या होता है? In this method, the wave beings added and have same frequency, amplitude, and the phases. As a result, the crest and the throw of the waves are in the element, and leading to a well-defined result waves. This type of wave addition is common in optics, and where light waves are combined to form inheritance pattern. Incoherent wave addition क्या होता है? In this method, and the wave beings and added to a different frequency and the amplitude and the phases, so the crest and the trough and of the waves are not aligned. The resulting wave is randomly combination of individual waves, and the amplitude and direction unpredictable, and this type of waves is common in field such as acoustic and the signal processing, and the various wave and the different sources are combined to form positive waves. In summary, coherent waves and the addition result in the is a well defined and the predictable resultant have, while incoherent and wave addition result in a random and the unpredictable wave. इनहेरिटेंस ऑफ वेव क्या होता है? इनहेरिटेंस इज द फिनोमिना ऑफ इन विच टू और more waves combine to form a new waves and with a lower, higher or the same amplitude than the individual waves. The amplitude of the resulting wave depend on the phases and the relationship between the individual waves, and the crest of the two waves and arises the same point in the spaces at the same time. The resulting which have a higher amplitude constructive interference. The crest of one wave arrived arrives at the same point as the through of another wave, and the resulting wave has a lower amplitude destructive interference कहते हैं इसको। ओके, उसके बाद इंटरफेरेंस ऑफ वेव क्या होता है? देखो, for sustainable interference to occur, the following condition must be made, and the coherence. It must be coherent, which means that they must have and the same frequency, amplitude, and the phases. देखो, septial and the temporal overlap क्या होता है? The most the must overlap in the both spaces and time. The path length and the path length differences between the two waves must be constant. Stationary condition and the condition of the mediums through which have passing must be stationary. Young's experiment क्या होता है? Young's is a classical demonstration of the interference of the waves, and it was performed by Thomas and the Young is in the early 19th century and is often to as a double slit experiment. In this experiment, light is passed through the two parallel split in a screen and the creating two sets of waves and that seen interfere and with each other, and the pattern that is observed on a screen behind the slit and in a series of bright and dark fringes, and which due to the constructive and destructive interference of the light waves. The experiment provides important evidence for the waves and the nature of lights and is widely used today in the optics and to demonstrate and the principle of inheritance and the diffraction. It also a practical explication and such as holography, and where the interference of light is used to produce three-dimensional image, जो यहाँ पे दे रखा है for constructive y is equal to n by lambda by d and so on. ओके, ये पूरा फार्मूला है, इसको ध्यान रख लें। इसको भी दोस्त को भेज देखो, जितने भी काम की चीज़ें वो सब सारे के सारे शेयर करते रहो। ओके, जिससे आपको हौसला बनेगा, बाद में फिर आप दोबारा उसको डिस्कशन करके अपने फ्रेंड से इजीली याद कर सकते हैं उसको भी। अब देखो सिंगल स्लिट क्या होता है। देखो, in the single slit experiment, light is passed through a narrow slit and the pattern of light that emerged on a screen and behind the slit is observed. When the light is passes through a slit and it diffracts or spread out and producing the characteristic patterns of light and darks and the fingers on the screen. The fingers are due to the constructive and the destructive interference of the light waves and emerge from the split, and the width of the finger depends on the wavelength of the light and the size of the split and the distance between the slide and the screen. It has practical application in the optics and such as in the design of the optical instrumental and such as the microscope telescope. Okay. उसके बाद क्या क्या गया तो the diffraction, the phenomena of bending light around the corner obstacle is called diffraction of light. उसके आगे डिफ्रैक्शन और इंटरफेरेंस में फ़र्क क्या होता है, तो भी काफ़ी इंपॉर्टेंट है, इसको भी अपने फ्रेंड को भेज दीजिए, कोई पढ़ के बहुत खुश हो जाएगा। उसके बाद क्या है, मॉलस लॉ, इसको भी भेज दो, याद कर ले। ओके, अब जानते हैं हम लोग पोलराइजेशन क्या होता है। पोलराइजेशन इज द प्रॉपर्टी ऑफ अ वेव दैट डिस्क्राइब द ओरिएंटेशन ऑफ इट्स ऑस्किलेशन। लाइट्स कैन बी पोलराइज्ड सो दैट द ऑस्किलेशन अकर्स इन अ सिंगल plane. Phenomena as known as a plane polarization and or the critical field can be rotated in the multiple planes and resulting in the circular or the elliptical polarization. Polarization also can also occur in the mechanical waves and such as the sound and where the vibrance and the direction and is restricted to a particular plane. Morse law क्या होता है? Morse law states that the intensity of light that passes through a lines and the polarization potential is directly proportional to the square of the coefficient and the angles between the planes on the polarization of a light and the plane of polarization of the polarization। मतलब क्या कह रहा था उससे फॉर्मूला ना समझो। मतलब ये जो इधर का जो नंबर है वो इधर के स्क्वायर का मतलब पोटेंशियल का मतलब प्रोपोर्शनल है, और जो इधर वाला नंबर है जो कि जिसको हम लोग बोल रहे हैं कि लाइट जो हो रहा है ना, लाइट इंटेंसिटी, वो जो डायरेक्ट प्रोपोर्शनल हो रहा है वो जो कॉस के स्क्वायर के बराबर है। मतलब जो सीधा बस फॉर्मूला को डिस्क्राइब कर दिया गया और यहाँ कोई डेफिनेशन नहीं लिखा हुआ। इस फॉर्मूला को ध्यान रखो कि मॉल्स लॉ ने कौन सा फॉर्मूला दिया था। ओके, उसके बाद हमारा है पोलराइज़र क्या होता है। ये एक ऐसा डिवाइस है जो अनपोलराइज लाइट को पास करता है, ठीक है ना। मतलब होता है क्या है, यहाँ पे जो जो भी पोलराइज जो होता है ना, जो भी पोलराइज या जो अनपोलराइज जो होता है लाइट जो होता है इससे पास करता है, ठीक है। इसी तरह कहो तो अ डिवाइस दैट पोलराइज द अनपोलराइज लाइट पासेज थ्रू इट इज़ कॉल्ड पोलराइजर। उसके बाद ऑप्टिकल एक्टिविटी क्या होता है। Optical activity: when a plane of polarized light passes through a certain substance, the substance of polarization of a light is rotated about the direction of propagation of light and through a certain angle. The phenomena is called the optical activity or optical rotation of, and the substance are optically active. Method of producing planes and the polarized light. The polarization of by the light: when the light wave is incident on a boundary between the two transparent media, and the portion of the light is reflected back into the original medium and the portion of the light is reflected into the second medium for a certain angle of the incident and the deflected have and the reflected wave interfere and the causing the reflective light to become a polarized. When while the reflected light is partially polarized is known as the polarization of the reflection, okay, by the reflection। अब देखो ब्रिस्टर लॉ क्या होता है। ओके, इसके बाद तो कुछ नहीं है हमारा, ये क्या है, ब्रिस्टर लॉ। तो आगे जाते ब्रिस्टर लॉ क्या होता है। According to the Bristol law, when light is incident and a boundary on a two transparent medium at a Bristol angle, the reflected will be completely the polarized and the reflected will not depolarized. Bristol angle is defined as the angle of incident which is reflected wave. It is completely polarized and given by the equation tan theta b is equal to n2 pi by the n1, and the where the theta b is the Western angle and the n1 is the index diffraction of the first medium and the n2 is the second medium, okay, reflection of the second medium। polarization of scattering क्या होता है। polarization by the scattering refers to the phenomena where light that is the scattered by the particles and in a medium become of partially polarized. This this occur when the scattered light waves interfere with each other and the causing scattered light is become partially and polarized. The degree of polarization of the scattered light depend on the size, shape and the composition of the scattering particles as well as the wavelength of the light and the angle at the light is scattered। Okay, so guys, thanks for watching video till the end, and you are don't forget that you are a part of journey of needs, so don't forget to like, share, subscribe. Bye bye and see you in next video.